In this video, I'm going to talk about the tangent line, tangent planes, and the normal line. So the tangent line, we we knew or we know how to find the tangent line, but what we need to focus on a lot is the tangent planes and the normal line because they are really has a lot of ideas that we need to focus on. But let's start with the tangent line. So for example, I will give you only one example to maybe give you a recap for or a review for what you took before, but that is okay. It's really simple and it's not that difficult. So for example, here, as you see, there is a question here came up and said find an equation of the tangent line to the curve x squared plus x times y plus y to the third is equal to 1 at the point 2 and negative 1. So to solve the equation of the tangent line to this curve, what you need to do, you need to solve it by using the implicit differentiation. So to start solving it, the first step that you need to write f comma x and y is equal to 0 because we said before that if we need to use an implicit differentiation way, you need to equal or you need to write the original equation with equal to 0. So you need to move this 1 here to the left and then it can be 0. So let's write it here. So we can write it as x squared plus x times y, then plus y to the third negative 1 is equal to 0. Now, now this equation here is ready to use for this implicit differentiation. So to start using the implicit differentiation, we said that we need to use the partial derivatives. Actually, there is another way you can solve it by the normal implicit differentiation that we took on calculus 2. You can use it by using the y prime. You can take the y prime and divide the both ways and the answer will be the same. But here we're taking the partial derivatives, so let's use it, or let's use the partial derivative way, I mean the implicit differentiation way in the partial derivatives. So we need to find the f of x, or f with respect to x and f with respect to y. So starting with respect to x here is going to be 2x and then plus y. So this is the partial derivative with respect to x here. Here is 0, 0. And the partial with respect to x here is 1. So what's left here is y. So this is the first partial. Okay. Starting or solving with the other partial with respect to y here. Here is 0. And here we will have an x, then plus 3y square. Okay. So here we found the partial derivative with respect to x and y. We said before that if we want to use or write the final step for the implicit differentiation, we write negative fx, which its partial derivative with respect to x over the partial derivatives with respect to y, right? So here we can write negative 2x plus y over x plus 3y square. Okay, so here everything is correct. What's left here that we need to use the point. So we will enter the point inside this equation. So here negative 2 times 2 is 4, negative 1 is going to be 3. Okay, so this is 3. Then uh here 2, we will have 2, then plus 3, then times negative 1 square. So we will have here negative 3 over negative 1 square is 1 times 3, 3 plus 2 is going to be 5. So the answer that we've got here is negative 3 over 5. This one means that we found the m. So this m, it means the slope, which means, so when you when you find an equation, or when you make this equation very simple, and when you enter the points, which means that you are finding the slope or its slope. So the slope here is equal to negative 3 over 5. So we are actually finished solving the equation. The last thing that we need to write is the tangent line equation. So we all know it. It's y minus 1 is equal to m times, in parentheses, x minus x1. So we can write it here. Here, let's change the color. So it's y minus y0, I mean, sorry, minus y0 is equal to m, then x negative x0. So if you use this equation, which means that you are finding the equation of the tangent line. So be careful. If the question say tangent line, so you have to use this equation. But if the question say tangent plane, which means you are writing really in a wrong way. So be careful which tangent thing does the question say. So let's continue here. So y negative y0. Okay, y0 is here. We are using the points and the m to find the equation of the tangent line. So y negative negative 1 here. So it's going to be plus 1. It's going to be equal. The m here is negative 3 over 5. Then x negative, or negative, yeah. Then here negative 2. So this is the final solution. You can make it really more easy if you multiply the negative 3 over 5 here, and with the negative 2, and if you move the y, sorry, the plus 1 to the right side, you can find the solution. But in general, this is the final solution for this question. Let's talk about right now the tangent plane and the normal line. Okay, so starting with the tangent plane and normal line, what you need to know in the first priority, there are some rules or equations that you need to know and also memorize, because you will use it a lot when you find, or when you solve an equation that told you find an equation for the tangent line and the normal line, for example. So there are some things that you need to be familiar with. So let's start with it. So, okay. So, first step that you need to know, that the surface, okay, the surface equation has an equation f of x comma y comma z is gonna equal to 0. Okay, so this is the first thing. So let me tell you the equation of the tangent plane to the surface. So there is an equation that you need to know, okay, for the tangent plane to the surface. So the equation is fx, partial derivative with respect to x, then x negative x0, this one x0, be careful, then plus fy, partial derivative with respect to y, then y negative y0, then plus fz, then z negative z0, then is going to be equal to 0. Okay, So this equation is really, really, really important. So you have to write it or memorize it. It's really important. لازم عن جد يعني هذا القانون لازم تحفظوه، أو إنكم مثلا تكتبوه أكتر مرة بحيث إنكم ما تنسوه وتعرفوا كيف تستخدموه. هلا بالأمثلة رح تشوفوا كيف رح نستخدم هذا القانون كتير. هذا قانون جدا مهم. So there is also another equation. Let me make some space here a little. So here we're removing. Okay. So there is also another equation called normal vector to the tangent plane. So the law tells you uh, fx x sorry x1 y1 z1 and then comma, then you write the second partial derivative fy, then x1 x1 y1, then z1, then comma, then fz, partial derivative with respect to x, then x1 x1 comma y1 comma z1, then we close the parenthesis. So this equation called, let me write it here, normal vector to tangent plane. Okay. uh last important thing that we always use, there is also another law called equation of the normal line. We can call it the parametric equations that we also knew or took from calculus 2. So the equations of the normal line, let me write here, equations of the um, normal line. Okay, so the first equation it's x equal x1 plus partial derivative with respect to x fx then times t. This is the first parametric. The second parametric equation is y equals y1 plus partial derivative with respect to y then times t. The third parametric equation, z equals to z1 plus partial derivative with respect to z then times z, and they are all, okay, t belongs to r, the real numbers. Okay, this is really important and we always use it sometimes to find the normal line, or maybe for example a question told you find the parametric equation, for example, let's say. So you have to be familiar with these. Last thing, we don't really use it a lot, but at least try to know it. uh, it's called the symmetric equation. Symmetric equations. The symmetric equation said or says x negative x1 over partial derivative with respect to x, okay, is gonna be equal to y negative y1 over partial derivative with respect to y, and then is gonna be equal to z negative z1 to the or over partial derivative with respect to z. Okay, so uh, try to know what the symmetric equation mean, or you can memorize it, but the most important thing is really for the normal line is this parametric equation. It's really, really, really important. So uh, enough talking. So let's get to the examples. Okay. So let's say, for example, uh, let's take, um, okay, let's take this one. So here, the example said, find the equations of the tangent plane, focus. He didn't say the tangent line, he said the tangent plane, okay? Okay. And the normal line to the surface. And he gave you this equation. He said the equation is x squared plus 2y squared, then plus z plus z squared, then plus y z is equal to 2. And he told you that at the point at P is equal to 2 comma 1 comma negative 1. Okay, so he told you from the question, tangent, you have to find the tangent plane and the normal line to the surface. So what you need to write, you need to write the equation of the tangent plane to the surface. So the equation to the tangent plane to the surface equation is, um, before I write the equation, I need to equal, or I need to make this equation equal to 0. So I need to move this 2 to the left side. Okay, so from here I can say x squared plus 2y squared plus z squared plus yz negative 2 negative, no, this is not z, this is 2, equal to 0. Okay, the equation says, let me write it here, f x, then x negative x0, or you can say x1, for example, it doesn't matter, x0 or x1, plus fy, then y negative y1, let's stick with 1, plus fz, then z negative z1, z1, then equal to 0. So from this step, what you need to find, we need to find the partial derivative from the original equation. We need to find the partial derivatives with respect to x, y, and z. So let's start finding the partial derivative with respect to x first, for example. Let's write here fx. So here we have an x, here yz, z, y. So all of them will be gone. So what's left here, the partial derivative is 2x. Okay, let's find the second partial derivative. We can write here fy. So x squared will be gone. 2y squared, its partial is going to be 4y. Z squared is going to be 0, plus we will have here, no, yes, plus yz. So it's going to be 4y plus z. And here minus 2 is going to be 0. So yeah. So the third partial derivative with respect to z, here is going to be 0, here is going to be 0, here we will have 2z, and then plus y. Okay, so the first step to write after the equation, you need to find the partial derivatives, okay, one by one. Then what you need to do, you need to enter the points after the step that you find the partial derivatives. So we need to enter these points here. Okay, so let's put the points here. So we will write here f of 2, 1, negative 1 is going to be equal 2 times 2 is going to be 4. Okay, we're done. The second step, here here we have fx, here we have fy, and then 2, 1, negative 1 equal 4 times 1, 4 times 1, 4, negative 1 is going to be 3. Okay? Is that correct or not? 4 times y, 1, negative 1. Yeah, it's going to be 3. The third one, fz, then 2, 1, negative 1. Here we have 2 times negative 1 is going to be negative 2, and then plus 1 is going to be negative 1. Yeah, let me check. I think there is something wrong. Yeah, sorry, forgive me. Here we have a wrong thing. Here there is a minus. It's not a negative. This one is 2. So what will change here? Um, Here we will have, yeah, there is really not a big thing. Here we will only have a minus. So only the value of this one is going to change. So the answer here is going to be negative 5. Negative 5. Yeah, forgive me. My bad. Okay, so here we have the final answers for negative 5 and negative 1. Okay, so everything is correct. So from here, we need to substitute those values and those points in the equation. So let's delete the things that we don't need to use. For example, here we don't need them. Okay, so from here, the f of x or fx, I'm going to substitute it with 4, and fy, I'm going to put it with negative 5, and the fz with negative 1. So here I can write 4, and here negative 5, and here negative 1. So from this step, I can remove those values that I don't need. Here, after I put the values fx, fy, and fz, I need also to put the values for the points. So the points are the those are called the x1 or y1 or z1. You can call them as x0. So I will remove also here the x1s, the y1s, and the z1s, and I will write them here also. So x negative is going to be 2, y negative 1, z negative negative 1 is going to be plus 1. So after we entered all the values that we have, just let's solve the equation right now and we will find the tangent line. That's it. Oh, sorry, the tangent plane. So 4 times x is going to be 4x, 4 times negative 2, negative 8, negative 5y, then plus 5, yeah, then negative z, negative 1 equal to 0. Okay, so here let's write here the 4x and then negative the 5y and then the negative z. Let's combine the 5 and the negative 1 and the sorry, yeah, the negative 1 and the negative 8. So negative 8, negative 1 is going to be negative 9, and plus 5 is going to be negative 4. So here is going to be negative 4, then equal to 0. So this answer is the final answer for the tangent plane. So this is the final answer, okay? But the question also said we need to find the normal line. So how can we find the normal line? We only let me make some space a little before I discuss it. Um, okay. Okay. So to find the normal line, as I said, we only use the parametric equation. So the parametric equations are x equal x1 plus fx times t, right? So from here, the x1, it's the value of 2. So we can write 2, then plus the fx, it's the value that we found its derivative. So it's 4x. So it's going to be 2 plus 4x, then times t. And this is the parametric equation for the x. Let's write for the y, for example. Y is going to be y1 plus fy times t. And then it's going to be equal to, the y1 is 1, so 1 plus, and here we have negative 5, so it's going to be negative 5y times t. Let's write, for example, for the z. Z is going to be z1 plus fz times t. So it equals to, the z1 is negative 1, so negative 1, and then we have also negative z, so we have negative z times t, and those are, we can write them t belong to r. Okay, yeah, and this is the final answer for this question. Let's take another example. Let's say, for example, the question says find the equation, or not find the equation, for example, find the tangent plane to the surface, of course. And let's say, for example, it gives you the equation 3x square, for example, then negative 2 times y square, then plus 3z square, then equal 10. And he told you at the points at p, negative 2 comma 4 and then comma 1. Okay, so we do the same previous question we did. So first thing, we need to make this equation is equal to 0. So we say f equal 3x square negative 2y square plus 3z square negative 10, then equal to 0. Okay, so this is the first step. The second step, what you need to do is to take the partial derivatives for x, y, and z from the original equation that equal to 0. Okay, so let's write here fx, and let's take its derivative. Here we have x, y, z, and a number. So taking with respect to x, all of those will be equal to 0. And let's deal with 3x squared. So its partial is going to be 6x. So dealing with f with respect to y is going to be 2 times 2, 4 with minus, so negative 4y, and all of them are zeros. Let's deal with the z variable. The z is going to be 6z, and this is it. Then what you need to do, you want to enter every x, y, and z points, you need to enter it here. يعني انت بعد ما تاخذ مشتقة القيم، بعد ما انت توجد القيمة بتروح بتعوض كل نقطة بقيمتها. يعني انت اوجدت مشتقة الاكس، بتاخذ نقطة الاكس وبتعوضها حتى انت تطلع القيمة. الواي نفس الشيء، بتاخذ مشتقتها من المعادلة، بتشتق الواي، بعدين بتعوض نقطة الواي، بعدين بتشتق بالنسبة للزد، بتروح بتاخذ نقطة الزد وبتعوضها بمكانها. بس هي. So let's take the derivative for respect to x right now. Let's say, for example, fx, then negative 2, 4 and 1. Okay, so we will enter only, or we will insert the negative 2 here. So we will say 6 6 times negative 2, so it's going to be negative 12. Negative 12, okay? So here we will say Fy, then negative 2, 4, 1 is going to be 4, no, minus 4 times 4, so it's going to be negative 16. So for the z part, Fz is going to be equal or of 2 minus 2, comma 4, comma 1 is going to equal 6 times 1. So Fz is going to equal 1. Sorry, 6. 6 times 1 is 6. Okay, so here we found the Fx, Fy, and Fz. So what we need to do right now, let me make some space. Yeah. What we need to do right now is that we need to write the equation of the tangent plane that we used in the previous equation. We need to find the tangent plane, so we need to use its equation, okay? After we use the tangent plane, we need to find the normal line. So let's start step by step. So first, we write the equation of the tangent plane, fx, then x minus x1, then plus fy, then y minus y1, then plus fz, then z minus z1, and yeah, it's going to be equal to 0, and that's it. So fx here, it's minus 12. So we will write here minus 12, then x minus x1 here is negative 2. So negative with negative is going to be plus, then 2. Then fy is negative 16. Wait a minute. Parenthesis. Yeah. Then yeah. Minus 16. Then y negative 4. Then plus 6 here, fz. Then z minus z1. So after we wrote everything we need, let's solve it right now. So let's say here it's equal to 0. This one is 0. Okay, so minus 12x, negative 24, negative 16y, then plus 64, this one is 4, then plus 6z, negative 6, equal to 0. So let's combine like terms. So we can say negative 24 plus 64, negative 6. So let's write the x, y, and z first. Negative 12x, negative 16y, then plus 6z. So negative 24 with negative 6 is negative 30. And we have here plus 64. So minus 30 plus 64 is going to be positive 34 and equal to 0. And yeah, this is it. This is the equation of the tangent plane. Last step that we need to find is the parametric equations of the normal line. The normal line, we need to use, as I said, the parametric equations for x, y, and z. So x, I wrote it before, it's x equal x1 plus f x times t. So here, x is going to equal, x1 is negative 2, so negative 2, then plus fx times t. Fx here is negative 12, so negative 2, negative 12 times t. Okay, so let's solve for y. Y is going to equal y1 plus fy times t. So the y for y1 is 4. So it's going to be 4. Then the fy here is negative 16. So it's going to be 4 negative 16 times t. The final part or the final solution of this question is the z. So z is going to equal z1 plus fz times t. Okay, so z1 is 1. So 1 then plus the fz here is 6. So 1 plus 6t are the normal lines for the x, y, and z. And this solution is the final answer or the answer of the tangent for the tangent plane. Okay, this answer is for the tangent plane, and these answers here 1, 2, 3 are for the normal line solutions. Yeah, this is it. Let's take another example here. As you see here in the screen, the example says x squared negative x times y times z equals 10 inverse of x times y times z at the point 2 comma 1 comma negative 1. Okay, so we need to solve it the same way we solved the previous two examples, and let's start. So the first step you need to do is you need to equal, or you need to equal this equation or make it equal to 0. So let's start writing f first. F is gonna equal x square negative x times y times z is gonna equal, I'm moving this tangent to the left side, so it's gonna be negative tan inverse of x, y, z, and then equal to 0. So this is the first step, okay? The second step that we need to do, we need to take the partial derivatives for this equation, taking it with respect to 1 first with x, second with y, and the third step to take it with respect to z. So let's take first partial. Let's write here, for example, fx, okay? So fx is gonna equal here 2x, then the second variables, let's say, x here is gonna be 1, so what's left here? Negative y times z, then negative the tangent inverse of x times y times z. X inside is gonna be times 1, so the tangent inverse, to take its derivative, you write the inside over 1 plus x squared, for example. The tan inverse of x, for example, is 1 over 1 plus x squared, but here you have x times y times z. Taking with derivative to x is going to be 1, so what's left here is y times z, and then here, instead of writing 1 plus x squared, here you have x, y, z, so it's going to be the same. So here 1 plus x times y times z, this one is z, yeah, times z square. So this is the tangent inverse. And yeah, this is it. And let's take fy, for example. Fy is gonna be equal, here it's going to be 0. In the second variables, we say here is going to be 1. What's left is negative x z, and then negative y is going to be 1. In the denominator is going to be x z over 1 plus x times y times z square. Yeah, and this is the second step, you can say. Yeah, let's find fz, for example. Fz is gonna equal here, it's gonna be 0, here it's gonna be negative x times y, then negative, and we say here the z is gonna be here x times y, because we took the derivative of the z here inside is gonna be 1, so what's left here is x times y, so that's why we wrote in the denominator x times y, and then 1 plus x times y times z square. And then let's put the variables, those variables, let's substitute them with every variable with x, y, and z. So 2 times, let's say here 2 times 2 is going to be 4. It's going to be 4. Then negative y times z. So negative 1 times negative 1, and then negative y times z. So 1 times negative 1 is going to be here negative 1. Then 1 plus x times y times z. So 2 times 1 is 2 times negative 1 is going to be negative 2, and then squared. And if you insert them, for example, in the calculator or something like that, you will find the solution is 16 divided by 5. Okay? You can try and solve it. The second step, let's put every x, y, and z. So here x, it's 2. So it's going to be negative 2 times the z, negative 1, then minus x times z. So 2 times negative 1 is going to be negative 2. And then 1 plus x times y times z is going to be negative 2, negative 2 square. So if you insert them in the calculator, the answer must be 12 over 5. Okay? And also the last solution, it's negative x 2 times y 1, negative x times y, it's 2, and then this one is 2, and then 1 plus negative 2 square. And the answer here must be minus 12 divided by 5. Okay? So this is the final answer, or for the first step, you can say. So let me clear those that I won't need anymore. Okay, so this question, let's say for example that we need to find the normal line. For example, if we want to find the normal line, we need to use the parametric equations, right? So to find the parametric equations, we need to say x is gonna equal x1 plus fxt. Also, by the way, you can find the tangent plane if you write the equation. So you have here the fx, you have the fy, and you have here the fz, and you also have here the x1, y1, and z1. Okay, Subs put them all together and solve it, and you can find the tangent plane, by the way. I'm not gonna write the tangent plane here right now because I need to show you something very important. So yeah, let's continue. So here x is gonna equal x1 plus fxt is gonna be equal here. X1 is 2, and then plus fx, it's 16 over 5, and then times t. So this is the parametric equation for the x. For the y, it's gonna be y1 y1 plus fy times t. So the y1 is 1, so 1 plus 12 over 5 times t. Let's say the z is gonna be z1 plus fz times t. Then it's gonna be equal to -1 and then -12 over 5. -1 I took it from here, and the -12 over 5 then times t. So here you can say that 100% the answer, let's say for example, is clear and obvious. But let's say for example, let's find something new. Let's say for example, find the intersection normal line with the xy, or sorry, with yz plane. Let's say for example that you were in the exam and he told you, after you found for example here the normal line, a question came up to you and said find the intersection normal line with yz plane. So what would you do here? Any ideas? So what you need to do here, that you need to think that he told you he wants you to find the yz plane, right? So which means that the x is going to be equal to 0, right? Let's say for example, if you want to find the intersection point with x and y, which means z is going to be equal to 0. Okay, so it's the same. So it depends on uh, which 2 points with its plane do you need to find. Like for example, xy, yz, xz. It depends. So here he said that he wants you to find the yz plane. So which means here x is going to be equal to 0. Okay, this is the first hint that you need to look for it for. Then let's solve for x. So take this equation here and solve it with respect to x, which means you need to write x equal 2 plus 16 over 12t, right? So here I said that x is going to be 0. Okay, so here for example x is 0, x here is 0, x here is 0. Then I'm moving the 2 to the left side, so it's going to be 16 over sorry, here it's over 5, not over 2. Then 16 over 5t, then it's going to be -2. Then I just solve for t. So it's going to be here 60 here with 1, and then equal -10. Okay, then t is going to be equal to, let's for example use the calculator. Let's say -10 divided by 16, and the answer is going to be -5 over 8. -5/8. Okay, so for this solution will help me to find the intersection points for every x, y, and z. So which means here t is going to be -5/8. Okay, so which means which means that here I'm going to find the x, for example. So I will say here x equal 2 times 16 over 5, and then times negative 5 over 8. What do you think the answer is going to be? It's going to be 0. So if it's not 0, which means that there is something wrong you did, because here, when the intersection y and z, we said that x is equal to 0, right? And my solution that I found the t is negative 5 over 8. So if x here is not 0, which means there is something wrong you did with your solution. So you can try it again. So the answer of t must be negative 5 over 8. ركزوا لازم يكون، بما انه عندك الانترسكشن y و z معناتها الاكس لازم يكون صفر. بما انه الاكس لازم يكون صفر معناتها الجواب انا اللي طلعته لما انا بحطه بالمعادله لازم يعطيني صفر. اذا ما كان صفر معناتها انت لازم تراجع حلك. Let's continue with the last step for this example. So here we have 1 plus 12 over 5, and then times t, and the t here is going to be negative 5 over 8. Negative 5 over 8. So if you use your calculator, the answer is going to be negative 1 over 2. So it's a negative half. And the last parametric equation, it's negative 1, negative 12 over 5, and then times negative 5 over 8. Negative 5 over 8. And then the answer, if you insert these values in the calculator, you can see that the answer is going to be 1 over 2. So it's a plus half. Anya, this is the final solution. So this is the final example of this video, and also the final example of this lesson. It's really different. Usually when we want to find a tangent plane or normal line, the things we get from the example, we get an equation and points. But this question is really different. So this question gave us its parametric equation and we want to find the points. بشكل عام الأمثلة اللي دائما بنحلها بيكون عندنا بالسؤال معادلة وبنفس الوقت بيكون في نقطة، مثلا نقطة واحدة بيكون فيها مثلا x y z. هي لا، هون أعطيك البارامتريك equation أنت بدك توجد النقطة. كيف بدك توجد النقطة؟ تابع معي وبتشوف كيف. So to start finding its points, we need to make this equation equal to 0 as usual. So we need to move these numbers to the left. So don't move the z. No, you need to move those values to the left side. Okay, so we need to write negative 7 and then negative 4x square and then plus 3y square and then plus z. So z is not moving, it's still here. And then equal to 0. So this is the first step. The second step, it's the normal and maybe the easiest step we all use. We need to find the partial derivatives with respect to x, y, and z, this equation. So taking the partial derivatives with respect to x here is going to be negative 8. Here, negative 8x. Here is 0, 0, 0. What's left here is only the x square side. So the fy Here is 0, 0. We have only 6x. 6 times y. And the fz, the last point, it's 1, only 1. It's only 1. Okay? So what should we do after this point? These parametric equations are perpendicular to the line, which means that if a line is if those parametric are perpendicular to the line, which means that also they are parallel to the normal line. Because they are parallel to the normal line, we need to write in we need to write in this way. So we need to make every x is parallel to its parametric equations. For example, here let's write, for example, these values first, and then you will know how can I write it. So first here negative x, okay? So here negative x, then 6y, then 1. So first step, you write every partial derivatives in a parenthesis or in a closed parenthesis. Then you write they are parallel to the normal line, as I said, because here they are perpendicular to the line. Then we open another parenthesis, and then I write let's say every parametric equations that have a t. For example, here I have 6t, so I write the 6 without the t's. And then the second value is 2, and then the third value here for the t is 1. This is it. Then I make every number equal to the other number, which means negative x is going to be equal to the 6, 6y is going to be equal to the 2, and 1 is going to be equal to the 1. So let's see where we go. So here negative 8x is going to be equal to 6, and then 6y is going to be equal to 2, and then 1 is going to equal to 1. But there is something. In this step, because we are writing everyone with the other place, we need to add a c. It's like a number, but we don't know what it is. So we need to write here a c. So 6c, and then 2c, and then here there is 1c. Okay? So here we need to solve the c, and here suddenly the c is solved like 1 or 1 equal 1c, which means here c is going to equal to 1. Okay? Because c here is solved, so we just need here only to just substitute c with 1. So 1 times 1 is going to be 2, and then 6y is going to be 2. Then let's divide 2 with 6 to find the y. So 2 divided by 6 is going to be 1/3. So notice here the points that we need to find are the x, y, and z, right? So the c is found. Okay, that's fine. Here, first step, we found the y. So the y is good. Let's find the x. The x here, 6 times 1 is going to be 6. So negative, or without negative, plus x is going to be negative 6 divided by 8. Then we can divide by 2. We will get negative 3/4. And this is the second point. And x is found. How do you think we can find the z? If you are really don't have an idea how to find the z, we can find it from here, from the original equation. Z is going to equal 7 plus 4x squared negative or minus 3 times y squared. So the x and y are found, and the z, this is the only thing we need to find. So put the x and y values with the y, multiply them here with 4 and here with 3, and plus them with 7, and yeah, the C is found. And the answer for the Z, if you are, for example, want to solve it, the answer for the Z is gonna equal to 107 over 12. It's gonna be approximately 8.9, and you can say that the answer is gonna be 9. So if you are want to know what Z value is. And yeah, this is it. بتمنى من الكل كان كل شيء كان واضح، وبتمنى كان كل الأسئلة وطريقة الحلول كانت كلها واضحة وبسيطة. بتمنى كان كل شيء مفهوم. I really hope everything was really easy and obvious. Comment down below if you need something, or write, for example, if you did not understand or you did understand, and I will really be very thankful to you. And yeah, in the next video, I will try to talk about the extreme values and the saddle point. And yeah, hopefully I will do my best to be doing good, and I will try to give you maybe some review and more example. For example, this video, I maybe gave you some like approximately 5 or 6 examples. In the other videos that I will make soon, I hope I will make like the same videos, examples. I mean, 5, 6, maybe 7 example. It depends on the time, because timing is really important. بتمنى من الكل، برجع مرة تانية بعيد، بتمنى كان كل شيء واضح، وشكرا لكم جميعا. Thank you all, and I'll see you in the next video. Thank you.